Good afternoon to all the lecturers and my friends. Today we are Group 6 going to present the service audit regarding the water supply, sanitary and sewerage system in UMSC. My name is Teo Si Yuan.
My name is Liu Zixing.
My name is Ain Yasmin.
My name is Lim Cheng Tong.
My name is Fazila Yusri.
And my name is Van Go Wong.
First part we will go to is the part A, which is the background literature and the case study regards this system in UMSC. First, I will explain about the objective. The objective basically for this proposal is going to explain the characteristic of the water, sanitary and sewerage system in the buildings. Next, we will be doing the plan checking regards the standard guidelines and requirements, and then conduct the POE, also the measure the physical performance of this system in the building. And the last one is we will propose a sustainable refurbishment plan for these buildings to fulfill the POE and also to achieve the objective. Next is the limitation. Due to the outbreak of COVID, so we cannot inspect the building, and also we cannot get the full building plan and also the information from the maintenance team in UMSC. Next, we also unable to carry out face-to-face interview with person in charge due to the MCO period. And also last one is limited response from the online POE survey.
I'm going to introduce UMSC. First, UMSC was established on 1998, which located inside the UMMC building. On 2007, the UMSC moved to its own building, and also UMSC is the third largest medical center, and it contains 95 beds and is located in Jalan Universiti Petaling Jaya.
For the digital review of the building service in theory and the general application, they have two systems we cover, which are the water supply system and sanitary sewerage drainage system. The provision of the water supply system is to deliver water to the consumer with adequate quality, quantity, and the pressure by the public utilities and individuals. The individuals is go through a pumping system and piping system. There are three main water sources that we can find from groundwater, rainwater, and surface water. The water is distributed from the street main to the respective building and to other fixtures like the tap.
For sanitary, sewerage and drainage system of UMSC is an underground pipeline system which collects wastewater to centralized treatment plants. And also, pipeline system is more than one pipeline network, and the manhole are constructed deep underground to provide access to the sewerage system.
So PPE is an approach that can be taken before, during, and after the project is done. The goals of PPE is to assess and track building performance. PPE also help organization to comprehend energy management system and ensure that detected issues is being assessed. Beside PPE, there is also POE, which is the feedback mechanism on the output of the building use.
The purpose of water distribution system is to distribute water to the user with appropriate quality, quantity, and pressure. Based on our observation, we conclude that UMSC building use dead end system as their layout of water distribution network. This is because the condition of the UMSC area. Dead end system is a system that contains a dead end in a part system and it does not flow continuously. There are several sub-networks in this system, which is mainline, sub-main, branch line, and service connection. So actually, this system is usually found in old area where the building are not well planned. As we can see, the X point is the excavation point for the water pipe distributor to supply water to the whole area of the building. So the water at UMSC building was supplied by Syarikat Bekalan Air Selangor, Syabas, which passed through the tap-off point with 85.67 meter ordinance datum level, then distribute to the whole area of the building. And to ensure the efficiency of water distribution system and adequate water pressure condition, there are three methods of the water distribution. First is gravity system, pumping system, and combined gravity and pumping system. So actually this method depends on the topographical condition of an area. In our observation, we conclude that UMSC building use pumping system as the method of water distribution. It is because UMSC building located at the high area with the height of 4,500 millimeter for each of the floor that consists of 4 stories. And pumping system method is a method that forces water to be distributed throughout the building. And the system uses a high power voltage of current to pump the water up into the building and be distributed. As shown in colored figure here, the red color line is incoming main pipe and yellow color line is bomba pipe. So facility used to deliver the water to this UMSC building are bulk meter, suction pump, water storage tank, hot water boiler, and firefighting water tank.
Alright, so I will present about the sanitary, sewerage, and drainage system service function in UMSC. UMSC. The plumbing system used in UMSC is one pipe system. It is only one vertical main pipe to collect the sludge water, which is dirty water, and the excreta, which is human waste. And the main pipe is ventilated at the top, and there is separated ventilation pipe is provided in the system. The water seal is protected and it has the anti-siphonage function. And for the manhole part, there is two manhole in the UMSC. The first one is MH1 manhole 1. The depth is 1.73 meter. It is proposed to be used for UMSC. The MH2 manhole 2, the depth is 1.79 meter and is connected to the manhole outside of the building. It is connected to the Jabatan Perkhidmatan Pembentongan manhole. And wastewater from UMSC will flow from one manhole to another manhole through the drain until it flows to the treatment plant. As we can see in the picture, the function of manhole is used to ease the cleaning process inside the sewer line. The second one is the basin, and third and fourth is the pedestal water closets and non-pedestal water closets. Second last is floor drain. This is used to prevent the flooding of water at the floor. And the last one is the rainwater downpipe. It is used to prevent the ingress of the water to the building and divert the rainwater away from the building.
So for next, we will come to the part B, which is the performance audit. The water supply system plan is checking by 4 guidelines, which is the JKR, Standard Specification Guidelines, Shabas Guidelines, UBBL, and also the last one is the JKR Mechanical System Design and Installation Guidelines. Inside the UMSC, the water supply system have been complied with these 4 guidelines with 61%, and then for another 37% is compliance based on the assumption. The assumption is made because we have limited access to the UMSC, and next is another 2% of non-compliances. The non-compliances in the UMSC for water supply system is not comply with the Shabas guideline. Inside the Shabas guideline, got the section 3.4.1a, number 7, is stated that the hydrant should be installed at least 91 meters before any pipe end. But inside the UMSC, the hydrant is installed 35 meters before pipe end. And the next non-compliances is the section 4.2.3b, number 6, which is stated that the water storage tank in building shall be subject to the approval of the Shabas and shall be in the list of the approved material of Shabas. But inside the plan, the material of the tank is not the approved of the material of Shabas, but it has get the Shabas approval. So this is considered as the non-compliance, and the material is hot dip galvanized.
For sanitary, sewerage, and drainage system, basically we check plans according to these 4 guidelines, which is the Strict Drainage and Building Act, Indah Water Consortium, and then UBBL, JKR. So based on our plan checking, we get the result, which is 46% is compliance, and also compliance based on assumption, which is 54%.
The standard requirement for specially outpatient is actually we take the source from the CCAPS ICL specialist clinic as the guideline to see whether the appliances and the space inside the specialist is comply with this guideline or not. Inside this guideline, we have the 57 compliances and 29% of compliances based on the assumption. And then next is the non-compliances, which is the 14%.
Now is for the POE on the building performance of UMSC will be conducted via the questionnaire survey. During this outbreak of COVID-19, so the respondent we get is very limited, which only 6 respondents. So for the gender of respondent, so there are 50% of the male and 50% of female. For the identity respondent, they have 3 staff of UMSC and 2 students and 1 visitor. In average, they have 3 staff of respondents spend more than 5 hours in UMSC, while other respondents, which are the visitor and students, spend 3 hours or less than 3 hours in the building respectively.
Alright, so I will discuss about the POE of sanitary system and sewerage system in the UMSC. So there are 3 issues faced by UMSC user about the sanitary and sewerage system in UMSC. The first one is the bad odor in the toilet. 50% of the user indicate that there are bad odor in the toilet because they said that there are human excreta in the toilet, and another 50% say that there is no bad odor occur in the toilet. For the next issue, which is the leakage problem, 2%, which is 33%, says that there are leakage problem at the female toilet, while the rest 67% represent by 4% say that they rarely seen any leakage occur in the toilet. The last issue is the water flooding scenario in the toilet. Only 1% say that they experienced this water flooding in the toilet, while 5%, which is 83%, claim that it never happened in the toilet in UMSC.
Through the POE survey, the current overall condition of the water supply system in UMSC is working on its requirement standard and has certified the occupants. However, they have some issue on the water supply system also. There is 1 out of 6 respondents reflect there is the water shortage problem in the building. For the experience on the tap leaking at the sink, they have 2% said that they have experienced it, and the remaining 4% claim that they had never seen it before. As for the hot and cold water dispenser provided in UMSC, there are 5% that enough for drinking purpose, while the remaining 1% claim that they have not enough. In the aspect of the water flow, the survey reflects that the current water flow speed discharge from the water tap and the pipe are good, which if 50% is considered fast and another 50% is considered moderate speed.
So next comes to the physical performance. Inside the UMSC, the water supply has been fulfilled with 5 performance. First is the water supply by the water storage tank, which is sufficient. The second one is there are 3 water storage tanks within the building, and according to the Shabazz guideline section 3.4.2 A number 1, it is fulfilled. Third one is the water shortage problem. We have referred from the previous report based on the UMSC survey that stated there is never already seen in the water shortage inside the building. And next, we have asking for the maintenance team about the routine water supply system maintenance frequency, and they have said that the maintenance is conducting 20 times per month, so it's considered as high frequency. And then the fifth one is the functionality of hot and cold water supply. Also get the info from the maintenance team in UMSC, which is in the good condition. Next is the calculation of estimated water consumption in the UMSC based on the water tariff formula in the Shabazz website, which is because we have get from the previous report say that the monthly water bill is 3,000. So use this to find back how much is consumed in 1 month by using the water tariff formula. So the total estimated monthly water consumption is 1,319, while for the daily is 44 meter cube. So next will be the performance of sanitary appliances by Ziqing.
Basically, for this part, refer to the senior report, as we cannot access to the building and check for the functionality of the sanitary appliances. So based on previous report, we can get the conclusion is all the sanitary appliances in the building is functions, and then it also well performed. And also we get recommendations about the sanitary system, which is there's insufficiency of toilet. Is because the outbreak of COVID-19, we receive a feedback about that the patient amount is reached to 350 to 500, which is not enough toilet for them. So, and also the next recommendation will be the cleanness of toilet. And also we receive a feedback that the cleanness of toilet need to be improved, and such as mopping the floor frequently and also clean the toilet frequently.
Okay, so next we are going to part C, which is innovative refurbishment plan. For low cost, we aim to fulfill the satisfactory of user based on the POE survey. For the medium and the high cost, we are going to achieve the objective of this proposal to propose a sustainable development, which is we reduce the water usage.
So the first problems for the low cost innovation proposal is to solve the problem of badly smell in toilet. So for first one, we suggest to put small potted plant, which plant is absorb carbon dioxide and release oxygen during the process of photosynthesis. And also this plant also act as a natural air purifier, which also can improve indoor air quality at the same time. So the plant that we suggested to place in the toilet will be snake plant. The advantage of snake plant is it's good in filtering out formaldehyde, which can be found in the cleaning product, toilet paper, and also other personal care product. For this snake plant, we'll place all the plants in all the toilet. The second one, we'll go through air freshener. So we also suggest to put air freshener in the toilet so that it can reduce the bad odor. So the air freshener that we suggested is removable air freshener gel. The advantage of this is it lasts longer with present aroma and gel is refillable. We also can eliminate bad odor in toilet. So for this air freshener, we'll place in higher place at the wall and also near the entrance at all the toilets so that it can avoid vandalism. For the third one, we will place toilet bowl cleanser. So this toilet bowl cleanser is used to reduce urine smell, which also can improve indoor air quality at the same time. The toilet bowl cleanser that we suggest is Lysol Hygienic Automatic Toilet Bowl Cleanser. The advantage of this toilet bowl cleanser is it can help to deep clean the toilet bowl and freshen the toilet automatically with every flush, and also it contains antimicrobial protection to resist the bacteria causing odor. For this toilet bowl cleanser, we will place in all the toilet bowl.
The second problem based on the BOE survey is they are not supply enough for the drinking water, which is the dispenser. So we propose the water dispenser, namely point of use water supply dispenser. The advantage is it does not require the replaceable water bottle for supply, and it is suitable to put in the public area to supply the cold and hot water. The location will be placed nearby the toilets at each floor. And for the costing in the low cost innovation for snake plant, and the total will be cost 165 since there will be placed 15 amounts, and the air freshener and total will cost 180. For the toilet bowl cleanser, the total will be cost 1,368 ringgit. And the last one is the POU water dispenser will be cost 1,300 per unit and will be placed 4 units, so total will be 5,200. And lastly, the total cost for the low cost innovation proposal will be 6,748 ringgit.
So for the medium cost innovation, we propose the dual flush toilet, which help to save the water. So basically for dual flush toilet is one of the toilet system which it incorporate two flush, which are the full flush and half flush. So for the half flush, maximum is consume the water is 6 liter and the half flush is 3 to 3.8 liters. So the reason why we propose the dual flush system is to replace the conventional toilet which is in UMSC due to 3 aspects, which is the environment impact, cost saving, and the low upkeep. So for the environment impact, as mentioned, that this toilet setting have 2 mechanism system. So unlike the standard toilet, they have only one flush operation. And for the cost saving, according to the study, the toilets can save around 67 of the water usage compared to the standard toilet. For the low upkeep, at the same time, the dual flush toilet is more easy to upkeep as it dispose of the waste by gravity, unlike the standard that use the pressure siphoning system.
Calculation of the estimated water bill in UMSC after using the dual flush toilet will be calculated using the formula from the Shabash website. For the estimated total monthly water saving calculated will be 438.3 meter cube water will be saved. And then for the estimated monthly water bill in UMSC, total will be 2,000 ringgit and 67 cents. And next for the estimated monthly water bill saving will be 3,000 minus 2,000.70 will be equal to around 1,000. And next will be the estimated annually, which is times 12 months, will be equal to 11,991.96 cents. And next is the return of investments. The return of investments, the total number of water closet replacement by dual flush will be 30, which is 15 female and 15 male water closet. And the initial cost, which is the installation and material cost, will be costing 400 for installation and the 500 for material, and end up will get the 27,000 ringgit for whole replacement. Next, for the annual cost saving where we save 11,991.96 cents. And next will be the payback period calculated as total investment divided by total cost saved, where we get 2.25 years, which is also equal to 27 months.
For high cost innovation proposal, basically it is to achieve our objective of proposal for sustainable building. So we propose for a rainwater harvesting system, which is the water we can use for the gardening, toilet purpose, outdoor ponds, and water features to reduce the water consumption. And also we can use this water for the essential part of healthcare process, which is to wash all the laundry from the healthcare usage. And the location of our water tank is above the ground outside of the building. Rainwater harvesting system used to direct it from the large surface, which is in our case it is roof, and the water will straight go to the gutter and rainwater downpipe, and there will be a filter unit to make sure our clean water only is being stored in our tank. And after that, there will be a filtering unit, and after the filtering unit, they will straight up went to the storage tank. And when needed, water is pumped directly to the demand points with the help of pump unit. To avoid the overflowing, the float ball in the tank will control the water sufficient, and if there is overflowing, it will straight away go to the drainage. And for the calculation, the total installation and material cost of rainwater harvesting system is RM 11,780 ringgit, and the total water usage in UMSC that was calculated just now was 15,828.1 meter cube, and it is equivalent to 36,000 ringgit. And total rainfall water yield was 3,844 meter cube per year. That is being calculated by roof area times with the drainage coefficient, which is 0.8 times with the annual rainfall. The maintenance cost for rainwater harvesting system is 1,178 ringgit per year.
For the return of investment of rainwater harvesting system, first we calculate the initial cost, which included the installation cost and also the maintenance cost, which equal to 12,958 ringgit. And also we calculate the annual water saved, which is approximately 24%, which equal to 8,640 ringgit. So from this, we can calculate that the total annual cost saving will be 8,640 ringgit. So the payback period we calculate using the formula total investment divided by total cost saved, and we get the payback period for this rainwater harvesting system will be 1.5 years, which equal to 18 months.
Last innovation for high cost is faucet motion sensor. This sensor is automatically on when it senses the presence of motion near the sensor. It is automatically open the valve and the water will come out through the faucet and automatically shut off when hand is removed. So actually the system is highly energy efficient and hygienic for the user because they doesn't have to touch the faucet itself. So we suggest to install this faucet motion sensor at every wash basin inside this building. So for the calculation, it will save 40% of water consumption per month. So based on the previous report, this building actually used 1,319.01 meter cube, and it costs 3,000 ringgit per month. So after the installation, the usage become 427.6 meter cube and costs 1,797.06 per month. So to be concluded, the estimate water bill per month for this building is 1,797.06 ringgit, and it saves 1,202.64 cents per month. And it can save 14,438.28 cents for a year. So for the ROI for this faucet motion sensor, it will be installed for 122 units, and the initial cost for installation and material is 50,123 ringgit 70 cents for 122 units of the system. And you also receive the rebate for 6% every purchase of 5 items. The cost for this is 811.42 cents for 122 units, and the installation cost is 49,312.20 cents for this faucet motion sensor. So for the payback period is 3.4 years or 41 months. The total for high cost innovation of water harvesting system and faucet motion sensor system is 61,092.40 cents.
For the conclusion, the innovation recommendation and proposal was done based on result from the performance audit to improve the performance of the building. We have proposed different costing proposals which are low cost, medium, and high cost. The total cost for the innovation proposal is 94,840 ringgit and 40 cents. The return of investment range from minimum 1.5 years and the maximum is 3.4 years. The ROI is still in the reasonable range and it able to boost the confidence among the stakeholders in the UMSC. Overall, this proposal has successfully proposed the sustainable refurbishment plan for the building services, successfully inspected the building services problem, and fulfill the building services requirement through plan checking and calculation. All the cross-learning outcome and the objective of the proposal has been achieved. That's all from us. Thank you.
Thank you.